Well, good afternoon, ladies and gentlemen. Thank you for the introduction. First of all, I want to thank Professor Najib Kayaus for his invitation as a keynote for this session. And yes, I think that the session for questions and answers are going to be at the end of the presentations. This is a very important topic that I consider to put on the table today, and it's engineering research and innovation for the integration of academy and society. Yeah, this is mine, so it will work. Yeah, thank you. No problem. Okay, well, yeah. This is the first picture I want to show you. This is a NASA image, and you can see there regions with a lot of lights and regions with not many lights. That can give us an idea of where technology is concentrated in the whole world. Because if we talk about population, we might see a lot of people, you know, around China, India, etc. So technology is not like related to the place where more people or much people is or are. Actually, talking about world population, we can see how it has exponentially grown from this latest 12,000 years. We might see here probably agriculture and here the Industrial Revolution, and you know, touching up to 7 billion inhabitants in this world. So as population increases, it will require more resources, and those resources must be pulled out from the earth itself. And natural resources must require engineering, because we have to come up with ideas of how to get all the resources as we are more and more inhabitants in the world. So engineering has turned many ideas into realities in the days. For example, applications in transportation, medicine, housing or construction, energy, and agriculture as well. So how do we teach this at the school, for example? Well, if we talk with elementary, the lower level of elementary school, we have to talk about technology, right? And technology is a matter of decisions, because when we have to apply technology, we have to think about costs, we have to think about benefits, and we have to measure the risks as well. So it's a thing of measuring, of weighing costs and benefits, but taking into account the risks. And how, for example, do we work on this special matter, which is global warming? It requires a lot of ideas in order to come up with some solutions. But how do we think or solve a problem that we don't really know? Well, mathematical modeling help out. We can create mathematical models and see the temperature changes with a projection with, for example, 2,100 and more. And also we can see the temperature behavior in the previous years. We also have to think engineering as a way of giving you a lot of beautiful projects. That's what I call engineering marvels. And one of this is the Panama Canal expansion project that was lately opened in Panama. And this is a very expensive project, and it was not built in 1 year, much more years. And basically, it was a great idea converted into a reality. Now, bigger ships can go through this canal, you know, enhancing the trades, the transportation of loads, and making the market more accessible and fast. But of course, we need to get regulation, because we cannot, like, all these ideas can be regulated. That's what I always say, that science and engineering has an impact on society. But also, it's not only one way. Also, society can impact science and engineering. For example, I love Mexico City. This is a picture of Mexico City. That's a huge city with a lot of people. And the times I've been there, I love to go to the Chapultepec Park and run in the park. But lately, the city has turned very foggy. There's a lot of pollution, and probably related to several reasons. For example, the population is now greater, and also a lot of cars, a lot of industry. So we will need to get regulations because engineering is also producing a lot of these things, but now we have to think about some other conditions that can appear in the future. And then, as I was saying, how do we teach this at the school? Because, as you know, we will need more and more engineers. I would like to ask how many of you are engineers? I mean, how many engineers are there in this classroom or in this room? Okay. So how do we teach this at school? Well, we have to talk about technology at the very low elementary school level. We have to talk about how ideas are becoming realities by means of engineering. Of course, taking into account that we are taking resources from the earth, natural resources that can even lead us to explore other planets. Like this is the Curiosity in the Mars surface. So engineering even reaches levels which are very high. If we move higher to, let's say, a high elementary school level, we have to talk about the time, because engineering solutions can be valid for a period of time. So we have to talk about past, present, and future. And I will give you a simple example. This is a Toyota Corolla, the most popular car along the years, but this is the current Toyota Corolla model. If we see this model, which is an Impala of 1958, you can see a tremendous difference. And that is because many things have changed. Design has changed. Fuel, let's say, the engine has changed. And probably this Toyota Corolla, which is working good right now, will be so different than the future concept cars, like this Mercedes. The system fuel is going to be different. The design is different. The aerodynamic, let's say, performance of the car is going to be different as well. So solutions, engineering solutions can change with the time. Everything, yeah, exactly.
He said that he can fix the first one, but not the second and the third one.
I need a neurosurgeon for the one.
For example, the driving system is going to change. Yeah, now you have some concepts where you don't even need to drive the car. The car, goes with some orders that are planned in your computer. But also, if you go to a higher level, you have to also consider the place. And it means, besides talking about past, present, and future, you also need to show them, the students, that the solutions can be different locally. It means that we have to weigh costs, benefits, and risks locally, and then finding some solutions for this problematic. So the point here is that we need more engineers. Since we are, being more people, we will need to get more people thinking of how to solve the problems of society, because engineers solve the problem, and engineering creates the bridge with science and society applies this. And then if you go to high school level, we also have to talk about regulation. As I mentioned before, science and engineering has impact in society, and society also impacts science and engineering. This is a picture when I was in Taipei about 5 years ago, and I went to the top of this building, which is the 101 building, one of the tallest skyscrapers in the world. And it was wonderful to see from that top the whole impact that society can apply on science and engineering. And this is what you have also to explain, that all the solutions may be different today and tomorrow. So I will now to go to this point. Which country in the world is producing more engineers? Well, I will show you this chart from the UNESCO World Economic Forum in 2015. And Russian Federation is at the top with almost 500,000 engineers in last year, followed by United States, but United States is producing almost half of this. And Iran. Always United States, Russia, and Japan have been at the top of this place. And well, China and India didn't have that available for this. Exactly, that's what I wanted to Well, this is by country, so I will go through more detailed information later on. But what I also want to point out is that some growing economies are producing engineers, a good amount of engineers now, for example, Indonesia and Vietnam as well. That's good for me, right? And now the question is, the question that you just said. I mean, how many of these engineers are Chinese or some other nationality? Or let's say, and how many of these engineers are women and men? Well, let's see where women earn the majority of science degrees. These are countries in which women earn 50% or more of the science degrees awarded. Yeah, science, okay? That's science. Or let's call STEM careers. So look, if I look at some American or Latin American country, I only can see Argentina and some other European countries, but Asian countries are at the top with women in science degrees. Interesting, right? Yeah. Now it gives you like a concern, right? Now let's see the percentage of female engineering professionals in EU countries, okay? There you have Latvia at the top with the 30% of engineering professionals. Only 30, okay? But then the lowest one is in the United Kingdom with almost 10%. So if you take, this is only in EU countries, okay? So if you take the average of this, it will give you a value between 30 and 12. So it's a very low percentage of women in engineering degrees. So what's going on? What's going on here? Well, now let's move to the US. This is the percentage of bachelor's degrees conferred to women in the US by major from 1970 till 2012. And there are a lot of careers here, but I would like you to focus on engineering. Well, in 1970 was just, about above zero, but in more than 30 years, it has only grown how much? 18%. So the growth has been very slow for this engineering career compared to, for example, business, marketing, or health professions such as medicine, dentistry, etc. So there must be some reason why engineering is not likely to be attractive for women. Let's go and see. Well, in average, the total engineers worldwide, 87% are men and only 13% are women. Is this good or bad? Well, let's reflect of this later on. This is the gender distribution of bachelor's degrees in science and engineering disciplines from 2004 to 2014. This is in the US. So you will see that engineering is above 20%. And it has, let's say, been stable, right, within these 10 years, compared to social sciences and psychology, which are even more than 60%. This is now the point. Why do high school girls think about engineering? According to Findings for Extraordinary Women Engineers in 2005, they have these answers. Well, first, engineering is for people who love both math and science. They even don't know what it is. They aren't interested in the field, nor do they think it is for them. And at the end, they mentioned this: someone who excels in math and science, someone who is motivated, dedicated, and who doesn't mind sitting in a cubicle all day. But you see, this is not a thing that is correct. I mean, being an engineer is much more than this. But how do we change this? Well, if we see the gender disparities in engineering in the US, well, about 17% of this intend to major in engineering, dominated by men. But almost half of this share is graduated. When we go to this field, only, let's say, 3% are intended, and of women are intending to major in engineering, and let's say 1 or even more than 1%. So the share is almost the same, which is very good. I mean, it doesn't depend on the gender. The big difference is how many women intend to major in engineering. So that's the big concern. There are also more things like underrepresented groups in engineering, the one you were mentioning. We have Asian, Black, Hispanic, and white. This is in the US, okay? And these are the words currently associated with engineering. The words that more are likely to think when you mention engineering. Okay, super smart people, math, problem solving, cars, science, drones, machines, innovative, confusing, cold, and this is very, very sad, right? Lonely, and this one, difficult. We have to change this because this is not completely true. I mean, come on. These are the perceived characteristics of engineers and scientists, okay? Scientists lately are more likely to be concerned to social goals than engineers. Look, according to this, only 14% of this are thinking that engineers save lives, compared to scientists, 82%. Wow. That engineers are sensitive to social concern, only 28%. Well, and nowadays, it has even decreased from 46% now to 28% compared to scientists. Now we are in the same field, which is STEM, science, engineering, technology, and math. Well, according to some studies, see solving the equation, they think that the humans are, let's say, driven by communal or agentic goals. And mostly women are likely to be attracted by careers which are linked to these goals, which are communal, like self-community, working with people, saving lives, attending to others, caring for others. Now, according to this study, men are driven by agentic goals, which is power, recognition, leadership, success, financial reward, mastery, and so on. So we have to change, the point here is that we have to change the message as engineers, saying how our career is about. These are the trends in percentage of female terminal degree holders. Well, first of all, I wanted to show the non-STEM, okay? Well, you see that it has grown a lot from almost less than 1% to 44.5% in dentistry, medicine, law, and business. But if we move to the STEM careers, engineering has grown, but only a little compared to other careers. Again, it's a matter of this. But what I want to show now is the difference between perspectives, okay? You can see here that when people see a problem from the same perspective, they are likely to get stuck on the same local fix. And this is something that you can see in this book by Scott Page, Diversity or Diversity Can Trump Ability, okay? This is like when they see a problem, since they all have the same perspective, they will stuck in the same point. But if you have a diverse group, they will come up with different points or different perspectives that can achieve the solution even faster or a better one. That's why society needs innovation. So what is innovation? Well, innovations can arise from rearranging the box. I mean, thinking out of the box with a new perspective from exploring the parts that have been ignored by the others. And also, diverse perspectives are more likely to lead very, very good breakthroughs and different approaches, which are more likely to get some iterative improvements. And when working in teams, most of the time, the diverse group outperforms the group of the best by a substantial margin. This is, again, by Scott Page and Lou Han, proceedings of the National Academy of Sciences. And they made some experiments, and they found that when they select a team from a diverse population of intelligent agents, a team of randomly selected agents outperforms a team comprised of the best performing agents. And again, more interesting, They found a random collection of agents drawn from a large set of limited ability agents typically outperforms a collection of the very best agents from the same set. Again, it's just showing that. The best problem solvers are likely to have similar perspectives and the similar approaches, while random problem solvers bring diverse ways of thinking. That's what gets and enhances the teams. And the best problem solvers as well get stuck at the same place. The random problem solvers no. So engineers, it's time to change how we promote the profession. And this begins with communication.
So this conference is the best possible conference because of its diversity.
Good, yeah, exactly. So let's change the words into these ones, for example. Let's call it engineers are innovative, imaginative, collaborative, they travel, they help, they contribute, they design, etc. And for example, this, I can start to explain this alternative energy as a very confused problem. By why don't I say that the world's 1.2 billion poorest people do not have access to electricity? So it's a way how to get the interest of the people. Again, with clean water, I can say that lack of clean water is responsible for more death in the world than war. So I'm giving a social concern instead of a very precise thing. It's the same like this. If I'm standing here and there is a piano falling down above, and some person just explained that a 200-kilogram object that looks like a piano is approaching your head at 9.8 meters per second square, come on, I will be dying. Why don't that person just say, look out? So, precision is the enemy of understanding.
Telling a person to look out. If you told me to look out, I say look out for what?
Okay.
You have to give some specificity. The best thing to do there is to kick the person out of the way.
Okay. That's another approach, even more effective. I will give you my experience. I can explain my work, my own research to the students from a precision approach and with another compare with some more accurate one. I can say that I perform computational simulations and wind tunnel tests of the airflow passing through an airfoil for an unmanned aerial vehicle with internal propulsion systems and analyzing the lift and drag forces and so on. The student is going to be like, what is it talking about? Why don't I say, first, my team is designing a wing for an airplane with no propellers, simulating the air with the aid of computers and experiments, analyzing the flow and the aerodynamic forces. And instead of putting this chart, which is complicated at first, I can come out with an image of the wing and more colors and more, to get more interest from the audience. So this is what I can, let's say, get. I mean, the preliminary messaging themes, ideas in action, life takes engineering, a limitless imagination, free to explore and shape the future, and an enterprising spirit. So how's this? Engineers are changing the world all the time. They dream up creative, practical solutions and work with other smart, inspiring people to invent, design, and create things that matter, such as alternative energy and clean water. These are the essential things of diversity, which is the most important because of the time is almost running out. Diversity is our best hope to address these challenges with truly innovative solutions. What are the actions? Well, tell people how your work makes a difference, change your bio, add a tag to your email signature line, use design or create instead of build, and tag about the people you work with. And also check your materials. Are they using effective messages? I want to finish this keynote with this quote by Theodor von Karman, which was a great one in fluid mechanics, and says that scientists discover the world that exists, but engineers create the world that never was. Thank you for your attention.